Hey folks, Mr. Farrell here. So I just wanted to put together a quick video on the free fall equation that we're working with in class because some of you all still might have some trouble working through the algebra with this equation. So this should help you walk through every scenario you could encounter where you have to rearrange this equation to solve for something. Okay. So for starters, just a little bit of background. The free fall equation is the equation we use whenever there is an object that is freely falling through the air. All right, the equation is this is a shortened version of a longer kinematic equation, which we saw in the video with Diana Cowan as she was talking about the kinematic equations and projectile motion. In short, the way we get here is if we assume that the initial velocity, the starting speed and direction of our object is zero, then we can actually cancel a term out from the kinematic equation, the longer one, and it'll allow us to get this shorter version here. If you want to look more at that, you can look at Diana Cowan's video again and just kind of review that for your own enrichment. However, once we get to this point, things become a little simpler to work with, but it's also just something that we might need to practice to be more comfortable when we come across word problems. So for starters, let's just identify all the variables we see. So we see delta y, we see a, and we see delta t. So delta y is the change in y motion, y position of the object. So the reason this is a y instead of an x is because y motion is motion that is up and down. X motion is horizontal motion. Y motion is vertical motion. So if an object is falling or rising up in the air, it's moving vertically. So that's why we're going to have y in a free fall equation because the object's falling down. So it's moving vertically. So again, delta y is just the change in position, not where it started falling from or where it hit the ground. It is how far did it fall? Okay, that total distance, right, and the direction it went. A is acceleration. Now, acceleration in the case of free fall is always going to be negative 9.8 meters per second squared. So you will never use this equation in this state for a free fall problem and not know what A is. You're always going to know what A is. So that is a given, but at the end of this video, I'll actually show you how to solve for A just for the sake of algebra enrichment, because again, you will not need to do that in a problem. The only things you'll need to do in a problem are solving for delta y or solving for delta t. But again, I'll just show you how to solve for acceleration just so you get the practice. All right, delta t is the time that has passed, the change in time. So not what time did you drop the object or what time did it hit the ground, but how long was it falling for, all right? Or how long was it going up into the air? Okay, so first we're going to start off by solving for delta y. And as we move into this problem, there are a couple things we need to review with the ICE protocol or ICE method for solving problems. So if we were to come across a word problem, we don't want to feel like we're in the hot seat. We want to keep a cool head, and we keep a cool head by remembering ICE. All right. So we want to first identify all the measurements and the question that are given to us in the problem. So first step for identifying, we know A is negative 9.8 meters per second squared. Let's say they give us some value for time, but they don't give us they ask us how far did the object fall. All right, so we know that our question, well, we would just mark all of those, identify those. The next step is to categorize. All right, so we know acceleration is negative 9.8 meters per second squared. We know that we have the time. We would categorize that using delta t, and how far, that question in the case of free fall, we categorize with delta y. So we identified everything, categorized everything. We are now at the equate step. So we need to equate the variable we don't know with something else, some expression, so that we can solve for it. Okay, so this is where we find an equation. All right, we are trying to equate delta y with some mathematical expression so that we can plug in these variables and get an answer for delta y. Okay, so here's our free fall equation, and it turns out that in order to equate delta y with something, we need to take our equation and get delta y in the numerator, and by itself, it needs to be alone on one side of the equal sign. So it is currently in the numerator, and right, because it is not underneath something, so it's not in the denominator, has to be in the numerator. Okay, so delta y is in the numerator, that's good. And it is also alone. It's by itself on this side of the equal sign. So we actually don't have to do anything else to get delta y by itself to solve this equation. All right. So in this case, we would just plug in our values for the acceleration due to gravity, negative 9.8 meters per second squared. And we plug in whatever value for time we got and make sure to square that. All right. And that's what we would do for the evaluate step. Now let's take a step back. Let's say we know how far the object fell. So I'll put a check mark there. But let's say we don't know how long it took to fall. So we would have identified the question and the measurements. We categorized them based on the variables we know. And now we are going to rearrange this equation because we need to equate delta t with something. So I need delta t in the numerator, and I need it to be alone on one side of the equal sign. Currently, delta t is in the numerator, so that's good. If it were not in the numerator, I would need to move delta t. But I actually don't have to move delta t because, again, it's in the numerator. So the next step is I need it to be alone by itself on one side of the equal sign. Currently, it is not alone. It is surrounded by other variables and numbers. So let me start by getting all of these other things away from delta t. So I'm not going to move delta t to get it alone. I'm going to move everything else away from delta t to get it alone. All right, so let's start with the fraction. All right, so in order to get rid of a fraction, you multiply by the reciprocal. The reciprocal is simply that fraction flipped. So instead of multiplying, so in order to get rid of 1 over 2, I multiply by 2 over 1. The reason is because 2 divided by 2 will give us 1. So those 2's essentially cancel out. And then 1 divided by 1 gives us 1. So I essentially have this expression times 1. All right. But we can say they cancel out. And that means the same thing here. So whatever I do to one side, I do to the other side. So I multiply by 2 over 1 here. I multiply by 2 over 1 over here. So 2 over 1 times delta y, that's going to be 2 times delta y here. And I can say divided by 1, but again, anything divided by 1 is just going to be whatever was in the numerator. So 2 times delta y is just going to stay the same. Now I have a times delta t squared. Okay. So now I still have to get delta t by itself. A is being multiplied by delta t. So in order to remove a, I need to do the opposite of multiplication, which is division. All right. Whatever I do to one side, I do to the other side. These a's cancel out, just like we saw with these fractions, right? A divided by a is equal to 1, which is the same as saying I can cancel them out. All right. So I get 2 times delta y over a equals delta t squared. Now, some people might say, okay, great, we got delta t by itself. We're good to go. But actually, there's still a number on this side, and that is this exponent. It is being squared. In order to get rid of the square, I have to take the square root. So delta t is not by itself yet. There's still another number on this side, and that is to the second power. So I'm going to have to square root this, right? Whatever I do to one side, I do to the other side. I square root this, so that I can then get rid of the squared, and I end up with delta t is equal to the square root of 2 times delta y divided by a. All right, now I have delta t in the numerator and by itself alone. So I have equated delta t with this expression. Now I can evaluate by plugging in all of my variables. All right. So again, that's all you'll ever be asked to do with this free fall equation is calculating or solving for delta y or solving for delta t. You're not going to be asked to solve for a. But again, I am going to walk through that here. So this would be good enough for you to do any work, class assignments, things like that. But I am going to just walk through how to solve for a just so you get some algebra practice. Again, you will not ever need to do this. Okay, so again, we get rid of the fraction first, multiply by the reciprocal. Same thing happens. 2 divided by 2 is 1. 1 divided by 1 is 1. They cancel out. I get 2 times delta y equals a times delta t squared. Divide by, I'm trying to get a by itself. So currently it's being multiplied by delta t squared. So I just divide by delta t squared. That entire parentheses exponent thing, I just can divide by the whole thing. So it's great. All right, those cancel out. So I end up with 2 times delta y divided by the quantity of delta t squared equals a. All right. And again, we'll always know a is negative 9.8 meters per second squared, but that's neither here nor there. All right. So great. Hope you all have a good one.